Now, let us look at the application of enthalpy. Let's consider a piston cylinder device that has a volume of 0.1 cubic meters and contains 0.5 kilograms of water at 0.4 MPa, or 400 kPa. Heat is transferred to the system until it reaches a temperature of 300 degrees centigrade, while our pressure remains constant. And we want to determine the quantity of heat transferred during this process. For us to begin, we are going to recognize that our heat transference is merely the difference of our enthalpy between our final initial state times our mass. That is, Q, going from state 1 to state 2, is equal to mass for a system times the difference of our specific enthalpy at state 2, less that at state 1. For us to determine our enthalpy at state 1, we need to know another system property in addition to pressure. And since we are given volume and mass, we can determine our specific volume at state 1. Our specific volume at state 1 is equal to our volume, which is 0.1 cubic meters, per our mass, 0.5 kilograms, or our specific volume is 0.2 meters cubed per kg. Now with our specific volume, we can determine our quality at state 1. Our quality at state 1 is equal to our specific volume minus our saturated liquid specific volume per our saturated vapor specific volume less our saturated liquid specific volume taken at 400 kPa. Or our quality at state 1 is 0.43. This allows us to find our enthalpy at state 1. Our enthalpy at state 1 is equal to our saturated liquid specific enthalpy plus our quality times the difference of our saturated vapor and saturated liquid specific enthalpies. Or we'd have an enthalpy of 1,522.27 kilojoule per kg. Now at state 2, we recognize that our temperature is greater than our saturation temperature, i.e. 300 degrees centigrade is greater than Tsat corresponding to 400 kPa, and thus we're existing as a superheated vapor. Our enthalpy at state 2 is found from the superheated steam tables to be 3066.75 kilojoule per kg. Thus, our heat transferred from state 1 to state 2 is our mass times the quantity H2 less H1. Or we'd have 0.5 kilograms times the quantity 3066.75 less 1522.27 kilojoule per kg, which gives us 722.24 kilojoules.